All right, let's crack open a cold case. A really cold one. We're talking 65 million years old. Today, we are on the hunt for a killer from space, and our investigation is going to take us deep into the world of our solar system's most mysterious drifters, asteroids and comets.
So here's the mystery at the heart of it all. For millions and millions of years, dinosaurs were the undisputed rulers of this planet. And then, poof, in the blink of a geological eye, they were gone. Something absolutely catastrophic happened, and all the clues point away from Earth and out into the blackness of space.
You know, the investigation really kicks off right here, in the dirt. Picture geologists digging through layers of rock. They're finding dinosaur fossils, everything's normal, and then, bam, they hit this weird, thin layer of dust. And the crazy thing is, this layer is found all over the world. It's the geological equivalent of a fingerprint left at the crime scene.
Okay, so we've got our crime scene, the entire planet, and we've got a key piece of evidence. This isn't just some story about an extinction. Nope, this is a whodunit on a cosmic scale. And to find our perpetrator, we have to look up.
So let's zoom in on that fingerprint. It's made of an element called iridium. Now, here on Earth, you just don't find a lot of iridium lying around in the crust. It's super, super rare. So finding a layer of it blanketing the entire globe, that's a massive red flag. But you know where iridium is common? In rocks from outer space. The clue couldn't be clearer. The killer came from the sky.
And here's the most chilling part. This layer of dust is like a final, undeniable line in the sand. You dig down, and below it you find a world teeming with dinosaurs. But above it, nothing. Silence. The impact and the extinction line up perfectly. So the big question is, who pulled the trigger?
It is time to bring in our suspects for questioning. We're talking about the small bodies of the solar system. You know, the leftovers from when the planets were being built. They've been drifting through space for billions of years, just waiting for their moment.
So here's our main lineup. In one corner, you've got asteroids. These are the rocky guys, the leftovers from the warmer inner part of the solar system where we live. And in the other corner, you have comets, their icy cousins, born out in the freezing cold depths of space. Different origins, different makeups, but trust me, both of them are more than capable of a knockout punch.
Now you might be asking, hey, what about dwarf planets like Pluto? That's a great question. Think of them less as a whole different type of suspect and more like a specific profile. They aren't some separate category. They're really just an asteroid or a comet that got so big that its own gravity squished it into a nice round shape. They're definitely still in the suspect pool. Let's start by putting our first suspect under the microscope, the asteroids. These are the rocky residents of the inner solar system. So, what's their story?
Here's the rap sheet. Asteroids are ancient. They're the rocky bits and pieces that never quite made it into a planet. Most of them are lumpy, potato-shaped, and covered in craters. We've found and cataloged well over 150,000 of them so far. The biggest one we know of is Ceres, which is big enough to be a dwarf planet itself, stretching about 1,000 kilometers across. And they're not all built the same either. Some are solid chunks of rock, while others are basically just loose piles of rubble tumbling through space.
Which, brings up a really interesting question. Most of these asteroids are just hanging out in this one area we call the asteroid belt. If they're all the leftover ingredients for a planet, why didn't they, form one? It really feels like there should be another planet sitting right there between Mars and Jupiter.
And the reason is a cosmic bully. The single biggest reason we have an asteroid belt instead of a fifth rocky planet is the massive, overwhelming gravitational pull of the biggest planet in our solar system, Jupiter.
The way it works is this thing called orbital resonance. The best way to think about it is like pushing someone on a swing. If you push at just the right moment in their swing, they go higher and higher. Well, every time an asteroid's orbit lined up with Jupiter's in just the right way, it got a little gravitational push. Over millions of years, these constant little nudges stirred up the whole region, sending asteroids crashing into each other instead of letting them gently clump together. Jupiter basically stopped a planet from ever being born.
Okay, let's move on. Time to turn our attention to the second group of suspects, the comets. These are the icy wanderers that drift in from the really, really deep, dark corners of our solar system.
Now, let me hit you with a surprising fact that kind of blows up what most people think they know about comets. When you picture a comet, you see that spectacular glowing tail, right? Well, the truth is, for almost their entire lives, most comets don't have tails at all. They're just dark, frozen chunks of ice and rock.
So how does it get that famous tail then? Well, it's a four-step process. Out in the deep freeze of space, a comet is basically just a dirty snowball. But as its orbit brings it closer to the sun, things start to heat up. That ice turns directly into gas, a process called outgassing. This gas creates this huge, fuzzy atmosphere around the comet called a coma. And finally, the solar wind from the sun pushes all that gas and dust away, creating the beautiful tail we see from Earth.
So where do these icy drifters hang out? Well, they have two main hideouts. The first is called the Kuiper Belt. It's a big, flat disk of icy objects out beyond Neptune, where comets tend to have pretty orderly orbits. But way, way farther out is the Oort cloud. This is a gigantic, spherical shell of maybe trillions of comets that completely surrounds our entire solar system. And out there, their orbits are totally random, going in every which way.
So we've profiled our suspects. We know where they come from, we know what they're made of. Now it's time to go back to the crime scene, deliver a verdict, and figure out what all of this means for us. Right here, right now.
The verdict is in, and the evidence is conclusive. Geologists have found the murder weapon, a massive 65-million-year-old impact crater off the coast of Mexico. The object that made it, whether it was a rocky asteroid or an icy comet, was about 10 kilometers wide. It hit with such force that it blasted a plume of vaporized rock, rich in iridium, all around the world, plunging the planet into darkness and causing a global extinction. Case closed. But closing that case just opens up a new, more urgent question. What's the risk today? Well, the truth is, Earth gets hit all the time. Tiny objects burn up in our atmosphere pretty much every day. Bigger, city-damaging impacts? Those happen on a scale of tens to hundreds of years. And the big one, an extinction-level event like what killed the dinosaurs? Those happen on a timescale of millions of years. The takeaway here is that it's not a question of if it will happen again, but when.
And look, this isn't just some ancient history lesson. As recently as 1908, an object only about 40 meters across exploded in the air over a remote part of Siberia. It didn't even make it to the ground, but the shockwave it produced flattened hundreds of square miles of forest. That's the kind of power we're talking about, from even a relatively small object.
And what about our old friend Jupiter, the cosmic meddler? Turns out it plays this really fascinating dual role. On the one hand, its immense gravity acts like a bodyguard, slinging countless dangerous comets right out of the solar system. But on the other hand, that same gravity can sometimes act like a bully, nudging a comet out of its safe orbit and sending it hurtling right toward us. And that leaves us with one final, really provocative thought to chew on. We know these objects can be destroyers, absolutely. They can wipe out entire ecosystems. But some scientists think that comets and asteroids may have been the very things that delivered water and the basic organic building blocks to the early Earth, the ingredients that allowed life to get started in the first place. So which are they? Cosmic killers? Or were they the unlikely messengers that made our own existence possible? Now that is a mystery for another day.